Welcome to all. See, today I will solve 3 more questions of same as last time. So it is compulsory that you should go through last class, then only solve this question. See, same, I won't dictate the question once again also. See, question given here. A block weighing 20 kilonewton is placed on a rough surface with the mu equal to 0.4. Then a force of 5 kilonewton, last time also 5 kilonewton applied, and to prevent the block from moving to right side, a cable is attached. See, this time inclined cable at 60 degree with vertical, the cable is attached. Find tension in the cable. What all I told last time, if you go through, understand, same statement once again write. See, write everything explained in last class. Those who are serious. So what we will do? Simple language. We will first imagine cable is not there. See, consider the block without the attached cable. See, they are applying a force of 5 kilonewton. The only change for this question is last time cable is horizontal, this time cable is inclined. That's the only change. So we will remove, what we will do? We will imagine, see, explanation. We will first imagine cable is not there. And do not consider 5 kilonewton and replace that 5 kilonewton force by a force P for which the block is on the verge of moving to right side. Okay. Again, limiting case. Consider equilibrium of the block. See, 20 R, P, etc. P will come 8 kilonewton. But applied force is 5 kilonewton. See, we are applying a force of 5 kilonewton. Block will start moving only when the force reaches how much? 8 kilonewton. So therefore 5 kilonewton force but applied for 5, block will not move because the applied force is less than the force required to move the block. Therefore the cable is inactive. See, when the block is not moving, see, I told you cable is inactive. Cable will become active. When the block is on the verge of moving, see, cable becomes straight. If you further move, then cable will be in tension. So cable is inactive, tension in the cable equal to 0. Okay, this is first stage. If the block moves, then second stage will come. But here, second stage is not there because we found that block is not moving. Due to that 5 kilonewton load, block is not moving. Therefore, what we will do? We will tell tension in the cable is 0. Cable is inactive. It is as good as not there. Even if it is there, it is not doing any, there is no use of that cable. Okay. Alternate solution or a direct solution, what you do is, do not do all this one. This is exam point of view better. See, in the question they told, a force of 5 kilonewton is applied to move the block. So the person who set the question, he thought that 5 kilonewton force will move the block to right side. So to prevent it, he is attaching a cable. Cable will be in tension. Okay, now let us assume the given force of 5 kilonewton will result in motion of the block to right side as per question. Now because of the attached cable, this motion is prevented. So FF limit will come. Let T be tension in the cable. Okay, now right. 5 equilibrium. Tension T, see, this is 60 degrees means 30 degrees here. Cos sine. Okay. Everything is clear here. Start. Sigma Fy 0, take upward positive. I will start from T. T sine 30 plus R minus 20 equal to 0, equation number 1. Sigma Fx 0 minus T cos 30 minus 0.4 R plus 5 equal to 0. Solve 1 and 2. Tension in the cable will come negative. See, if you are doing this question, if you are solving this way, this is not there. If you are solving this way, that is not there. Okay. T will come negative, right? Negative means cable, instead of T acting this way, it should be acting this way. Cable cannot take compression. The negative value indicates that the cable is inactive. First of all, the cable is not required. So right here, class. So don't write minus sign here. Answer is not minus 4.504. Answer is since the cable can take only tension. So since negative sign came, the block is not moving, tension in the cable equal to 0 is your solution. direct solution. Okay, now question number 18. This is to save the time. A force of 8 kilonewton applied. See. Once again write the question, full statement you write. Okay, now all same statement, you replace that 8 kilonewton force. See, they are applying a force of 8. What you do? Don't consider 8. You find at what force the block is on the verge of moving. So it is P. Solving, we get 8 kilonewton. Oh, see, that is right here. That is, the block is on the verge of moving when you apply a force of 8 kilonewton, and actual applied force also equal to 8 kilonewton. That is, when the 8 kilonewton load is applied, force is applied, the block is on the verge of moving. So still, cable is no use. Cable will come into picture when the block starts moving. Therefore, tension in the cable T equal to 0, or cable is inactive, but it is about to participate now. See, you are on the verge of moving. So no one will prevent you from moving. The moment you move, then someone will prevent. Or, okay, if you are not doing this way, see, from the question, directly jump here. You assume that 8 kilonewton force will move the block as per the question. Write 8 kilonewton. 8 kilonewton. Solve. Same thing, same as last time. See, only change is, see, T sin 30 plus R minus 20, 0. Equation 1 minus T cos 30 minus 0.4 R plus 8 equal to 0. When you solve 1 and 2, your tension in the cable will become 0. Oh, 0 will come. 0 tension means the block is on the verge of moving when the force is 8 kilonewton. Okay, this is our question number 19, last question of today's class. See, because I told I'll be out of station, long class I can't upload, 19. Last time how much? 15 kilonewton, okay. I change the question. Once, see, you should not, what I am doing, you should not do it. You should solve the question independently. Question is, load applied is 15 kilonewton. So, this solution, replace that 15 kilonewton force by a force P, or they are applying 15, what you do? You don't consider 15. You find at what force the block is on the verge of moving. Solve. It will come 8 kilonewton. Okay, then. But see, that is right here. That is statement. The block is on the verge of moving when P, applied force P, reaches 8 kilonewton. Yes, but the applied force is 15 kilonewton, which is more than 8 kilonewton. 8 kilonewton means this 8 kilonewton. See, the block is on the verge of moving when the force reaches 8. But you are applying 15, therefore, right here, therefore, the block will move. Block will move. Therefore, now the cable will prevent the motion. Let T be tension in the cable. Tension in cable. Now do one thing. Don't see that side. See. Don't see that side. Don't see this one. Okay. Start. Right. This will come here. What you write here? 15 kilonewton force. 15 kilonewton. Okay. Solve like same as last time. This 8 will become 15 here. See? Plus 15. I don't know why it's happening. Plus 15 equal to 0. Don't see that side. This is not there. Solving, your T will come 10 point. I already solved it there. Plus 10.510 kilonewton. Yes. So therefore, see, the block is on the verge of moving when the force is 8 kilonewton. When you apply 15 kilonewton, the block will try to move. The cable, tension in the cable will prevent it. So the tension required is 10.510 kilonewton is this solution. See, after all this one, now second stage is there. Don't see that one. You write this one over. Now, I'll remove this one now. Or direct solution. Let us assume that the given force of 15 kilonewton will result in motion. Once again solve same way. Answer will come 10.510 kilonewton. This time checking is not there. See, that 8 will not come. You directly apply tension T and find the force. It will come 10.510 kilonewton. So last time 3 question, that is question number 14, 15, 16 last time, where cable is horizontal, and today's class 3 question, when cable is inclined, if you study correctly and understand, your concept will increase, that's all. Okay, now I will go to next part in the next class only. Today I am winding up because I told same problem, I told the problem. Now new part. Okay, thank you. We'll meet in the next class.